Okay, so now we're going to look at charging systems, testing, and service. So you're going to get customers that come in and say, yeah, I don't think my alternator is working again. Check the easy things first. You know, check the belts. Again, if you've ever been in a vehicle and you first start it up and you're sitting there on idle and you turn a bunch of accessories on, you hear the RPM of the engine drop. And that's because the rotor is producing a magnetic field. It's basically an electromagnet. And what it's doing is it's creating drag on the engine, which slows it down. So if the belts are loose, the belts could slip, especially if the demand is high. So check the easy stuff first. Some of the things I've had customers come in and they said, yeah, my voltmeter, or I don't think it's charging. So some really quick, easy checks, we don't have to disassemble or disable anything to do some checks, is shut the vehicle off, go to your battery, put your voltmeter on there and see what your open circuit voltage is. Start the vehicle up. Does that voltage go up? If it does, then it's charging, but that doesn't mean that the alternator is good. That the alternator is charging, but maybe it's not charging the capacity that's needed. So we may have to load test and make sure that the output for that alternator is what it says on the case. So for instance, if I have this 150 amp alternator and my demand on the system is quite high, but not to 150 amps, but if I have a problem internally and it can't produce the amperage that's needed, eventually it's going to drain the battery down. So these are the things, and this is what we're going to go through to make sure that the output of that alternator is close to what the recommendations or what the specifications are of that alternator. So again, some easy things to take a look at. Oil soaked belts, belts that are starting to come apart, belts that aren't even there. I had one customer come in and he said, I don't think it's charging. I went and looked and there was no belt. So easy fixes. When we're checking pulleys, now we've gone more to the serpentine belt, and that's because we have more surface area and contact, less chance of slipping. But when we get into the V-belts, as the V-belt wears in, it's going to wear a dish into this pulley. Now, I put a brand new belt in there, it's not going to have full contact, and we run the risk of that belt slipping prematurely. So we want to make sure that if we're replacing the belt, that the pulley's still in good shape. So on our serpentine belts, again, as they start to get old, they start to get cracked and they start to get worn. I had one customer come in and he says, I think I need my belt changed, and what it was is there was only each of these ribs that were running around there. It was running nice and straight, but it did just wore out. So there wasn't much left. So when we're putting belts on, making sure that our belt tension is where it's supposed to be. If we don't have a belt tensioner on there, again, how tight is tight enough? We don't want it too tight, but we also don't want it too loose. So on some of these tensioners, they will have a mark where it'll tell you whether it's too tight or too loose. So again, making sure that the belt that is required for that vehicle is the right length, and not too long or not too short. The other thing that we have to pay attention to is the alignment of the alternator. Now, there's a couple things when we take a look at the case that we should be aware of. So for instance, if we have our alternator here and it's mounted, is it in alignment? Is that belt running true? Because if it isn't, it's going to wear out prematurely. So we've got to make sure that when we're installing the alternator, if we're installing a new alternator, that it is in alignment. Now there's a couple of things that can happen that can cause it to come out of alignment. Now, on this type of an alternator, we have this style of pulley. You can see it's got a built-in aluminum washer that fits on this, so again the pulley's going to go over this and hold it on tight. But you're going to get some of these that don't have the built-in washer, but there's a steel washer that fits in there. So if it already has a washer in there and I take one of these and put it on, tighten it up, now my pulley is further out than what it should be, and it'll be out of alignment. So always, as you're taking it apart, make sure. So ones that have that bushing inside, you'll have a plate that doesn't have that bushing built into it. The other thing that we see is these bottom mount bolts. Now, this bottom mount bolt here has a sliding collar. Now, there's not a lot of resistance in there, but you can tap that with a hammer just to make sure that it's free. If we put this in and we tighten this down, we can actually snap this ear off if we use an impact. So be very, very careful when you're tightening up these two bottom bolts. On some of the alternators, you'll see there's just a single bolt that runs through. And I've found sometimes I get out to the vehicle and someone has forgot to tighten those up. They've adjusted the belts, but they forgot to tighten these back up. And as the alternator moves, it starts to wear them out. Now the alternator comes out of alignment. So this is what you're going to see. Broken bushings, ovaled holes, again, if anything's left loose. Now, how do we go and test? Well, what we're looking for in an alternator is we don't want any more of a voltage drop than half a volt on a 12 volt system, 1 volt on a 24 volt system. Always remember, anything that's on a 12 volt is always twice the amount for a 24 volt system. So what we want to do is we want to go from our positive of our battery to the positive of our alternator. Now what we're going to use is a carbon pile. And we don't want to put I don't like this idea of putting a carbon pile on the alternator because we can actually wreck an alternator. I'd much rather put the carbon pile on the batteries, draw the batteries out. It will tell the voltage regulator to go to full field. So if we put our carbon pile on our batteries, load our batteries down, and check our voltage drop between positive, positive, and negative. That's going to let me know if I have a problem with either the positive side or the ground side. Okay, inside the cab again we could have an 88 gauge, and these, again, they give you a rough idea. I had one customer come in and he says, yeah, I don't think it's charging. I went out there and I checked the battery, I checked it, and it was. What it was is the gauge didn't quite read what it did 2 weeks before, so I have two options. You can just leave it that way and he'll know, or they can change the gauge. So overcharged batteries. Again, it could be overcharged and it could be swollen. We could have electrolyte leaking out. So this is a problem with the voltage regulator, because the voltage regulator controls what's going on in the battery. But we could also have a problem with the battery that has low resistance. So most of our vehicles now, especially off-highway vehicles or highway trucks for that matter, they have more than one battery. So the battery that has the least amount of resistance is going to take the most amount of charge. Now it can overcharge a battery, and that's why we should always be changing batteries in sets, so that they all have the same internal resistance, so they all get charged the same amount. So when we take a look at this picture here, okay, so this one here has a high resistance. So again, with a high resistance, what's going to happen? It's not going to be able to take a charge. So the rest, these two here, are going to get most of the charge, where these two aren't. So they go out in the morning and the vehicle won't start, or the machine won't start. Well, it's because this set of batteries has a high resistance to it. We can also run into the same thing with a low resistant battery. So if we have normal resistance in some of them and we have a very little resistance in another, the one that's got the lowest amount of resistance is going to charge the fastest. And the pushback, and it may overcharge it. Okay, we also talked about open circuit voltage. Now, on a fully charged battery, our open circuit voltage is roughly 12.6 volts. Now again, that doesn't mean that the battery capacity is good. It means that our voltage is up there. But number one is we always want to check our batteries first before we do anything else to make sure that all of those connections are good and our batteries are good. Then what we want to do is we want to check to see what's going on with our alternator. Now, one of the things that gets overlooked a lot is a thing called ripple voltage. Now, ripple voltage is AC voltage that has leaked past a diode. So again, we discussed a diode needs about 1/2 volt to trip open. So as the stator is taking that current and pushing it out through the diode, it has to trip a diode open and then the diode closes. What ripple voltage is AC voltage that gets out past the diode. Now, we allow 1/2 volt of ripple voltage on a 12 volt system, 1 volt of ripple voltage on a 24 volt system. But how do I check ripple voltage? What I'm going to do is I'm going to take my meter and I'm going to hook it to the positive stud. So my positive stud to ground. But I'm going to have my meter set on AC, not on DC. Because it's AC voltage that we're looking for. And why would we get a lot of ripple voltage? Let's just say I've got a diode that's shorted. That means that voltage can come in and out. So I can actually get leakage out of that. So that's one of the checks is if it's not charging fast enough, we could get AC voltage coming out of it. Okay, so we check this. Our voltmeter should read up to 14.5 volts. But we also want to put a amp clamp on there and load down the batteries to tell that alternator to go to full charge. And see what kind of amperage we're getting out of the alternator that's feeding back to charge the batteries. Now, just starting the vehicle, turning all the lights on, it will bring it down. But if I have a 150 amp alternator, there's no way by turning all my heaters and all my lights on that I'm going to get a draw of 150 amps. I can't. So what I want to do is I want to load down those batteries to simulate the draw. And again, we're going to know what our amperage output of our alternator is before we start. So I might have one that's 150 amps. I might have one that's 50 amps. So knowing what our alternator output is critical. Okay, so this is what our reading should be when we're checking across here. And again, loading down on the batteries and not on the alternator. And this will put this basically into full field and it will read what our output is. So our amp clamp is going to tell us what our amperage output is and our voltmeter is going to tell us what our voltmeter reading is. Now, these are a couple things we're going to go through on some of the issues that we see. So if we have a whining noise, now a whining noise is caused by a short in our stator winding. So again, a short, it's not short to ground, it's just a short between 2 points. So what happens in a case like this is this leg and this leg will still produce maximum amount, but because the short in this one, it won't. So how big the short is will determine how much less output we get. So let's just say this is a 150 amp alternator. We have 50 amps here, 50 amps here, and 50 amps here. But if we have a short, if it's just a small short, it may only be drop 5-6 amps. But let's say it's got quite a short, so let's say instead of being a 50 amps, it can only put out 20 amps. So when we load test it, what's going to happen is instead of having close to 150 amp output, we're going to end up with 120 amps. we know that there's something wrong internally because it should be really close to 150 amps. So as we go to full field, we'll hear that whining noise coming out of the alternator. Another one is if we have an open stator winding. Now again, let's just say we have a 150 amp alternator. Each leg should produce approximately 50 amps. But if we have an open stator winding, that leg is dead. So what's going to happen is it's going to decrease the output by 1/3. So if we have a 150 amp alternator, it's going to lose 50 amps. We're only going to be able to put maximum of 100 amps out. Now, if we take a look at our rectifier bridge, now, remembering what an open and what a short is. So if we have a shorted diode, it means I can have forward and reversing bias through that diode. It means current can go both ways. And what's going to happen is I'm going to lose 2/3 of my output. And why is that? Well, as current is induced in this leg here, again, path of least resistance. If it can get back this way, it will. Same with this one here. So it's not going to go out to charge my battery. But what happens then is when this leg is providing power, it's the only one that can actually charge the battery. So again, when we have a 150 amp alternator, when I load it down, it only puts out 50 amps approximately. We know that we've got a shorted diode. Now again, let's just say that the demand on the vehicle is 70 amps. We're only putting the maximum of 50 amps out, so eventually it's going to deplete that battery to the point that it won't start. Another thing that we should be looking at is how often does a vehicle get started? So if a vehicle gets started, for instance, a forklift on a loading dock gets started 20 times a day, it may not have time to recoup. So every time we start it, it's drawing energy out of that battery and it can't replenish it fast enough. So what happens when we have a diode that is open? So what that means is if it's open, nothing can go either way. So now we'll be reduced by 33%. Again, it's like having a broken stator winding, because this one here can't complete the circuit because it's open. So we're only getting current out of this one and this one. And again, when we load down the batteries, our output's only going to be around 100 amps. We know that there's something wrong internally. So how do we check some of this stuff? Well, first thing before we tear an alternator apart, and these are pretty idiot-proof, but we should be marking the cases. And again, be very careful. Just either use this or just a little punch mark on there, so we know how to orientate them when we put them back together again. Like I say, they're pretty idiot-proof, so common sense. So when we take our pulley off, again, we want to make sure that we support it properly so that we don't break anything internal. When we're doing our inspection, broken fins that are on our cooling fan. So again, if you take a look at these, they're balanced because they do spin quite fast. So if I've got a broken fin, it's going to vibrate. When I'm taking my alternator apart, now one of the things when I pull an alternator apart, once you pull this apart, the brushes are going to pop out. So before we reassemble it, we have to go in and we have to hold these brushes away from the slip ring so we can assemble it. And I usually use a toothpick. So if you take a look in this one here, there's a little hole right here. And if you take a look on the inside, that goes up through the brushes. And what you'll do is when you go to reassemble, you're going to put your two brushes, push them in, put the toothpick in there, and then when you let go of the brushes, they'll stay away. So when you assemble it, you pull the toothpick out, then the brushes will go in and seat against the slip rings. If you forget to pull it out, it won't charge. Okay, so as we start to disassemble, what are the components inside? So if you take a look here, if you can see this, this is our rectifier bridge that has our 3 negative and 3 positive diodes. This is our voltage regulator, and then in here is our diode trio. Now, how do we test? We've already learned how to test for a diode. For forward biasing and reverse biasing, we're going to set the meter on our diode setting because we want to know at what voltage it trips that diode open. So here's my rectifier bridge, okay? So this is my negative diodes, this is my positive diodes, and you'll see 2 sets of copper straps across here. So if you separate them, we can now test each one of these. We can put our ground clamp here, we can test this one, and this one. Because they're pressed into this aluminum housing, there'll be a common ground. Then we're going to switch it around and we're going to check the other way to make sure that in one direction, like forward biasing, they're all working, but in reverse biasing, it's all blocked. Then we're going to do the same with the positive diodes and check them to make sure that they're all working properly. And we can do the same thing when we're going in and checking our diode trio. So depending on the type of rectifier bridge we have, how we can check it. Other thing we want to check is we want to check our stator. Now, the most common thing that we're going to check for is a ground. Because if I check from here to the case, because these are all hooked together, any one of these will show a ground. Now, if I go in and I check from ring terminal to ring terminal, think about it. What's going to show up? Unless I have 2 opens. Again, if I take a look at a delta style, and I've got my 3 ring terminals, let's just say that, let's say I've got an open there. If I check from here, whoops, if I check from here to here, it's going to show continuity. If I check from here to here, it's going to show continuity because it can get through this way. So we won't know if this has got a short in it. The only way we're going to know that is by having it on a machine and loading it down. So before we strip an alternator apart to check to see what's wrong, we should always do a load test on it, and it'll give us an idea of what to start to look for. Because let's just say I have 1/3 less output. Okay, so it could be a bad diode, could be an open diode, or it could be a stator winding that's open. Now, if I go and I check this here and my diodes are good, I know it's not this, it has to be this. So we want to check our continuity. What we're doing is checking for resistance. We should have very little resistance between any 2 points. If we have a high resistance, it means we're going to have problems charging too. Now, what are some of the things that can cause high resistance? Well, let's just say I have a bunch of corrosion in there that's creating a resistance. It may not be able to put the output again. So checking to make sure what our continuity is. The other thing we want to check is on our rotor. What we want to check is make sure the slip rings aren't grounded. The slip rings are insulated from the shaft. So if we check there and we have an open, which is good, that's what we want, we don't want any continuity, but if it shows something up, that means that one of the slip rings is grounded. Now, a couple of things that can happen is, depending on what slip ring it is, it may not even show up on an alternator test, because remember the A style and B style. So if power comes into this one here, goes through my rotor and comes out to here to ground, if I have a B style, which is the power side's being controlled, and this slip ring is grounded, it wouldn't matter, it would never even show up. But if it's an A style where my voltage regulator is after this and this slip ring is grounded, it's going to full field it. Then we want to check from slip ring to slip ring. Now, again, we're going to have internal resistance within that coil of wires. We can find the specifications on an alternator and find out what the internal resistance should be of the rotor. Now, here again, if we have too much resistance, we could end up with an issue, or if we have no resistance, we have a short. So it's not going to charge because we can't build that magnetic field. The other thing we can do is we can check to see what the current draw is by hooking up an amp meter. Hooking up the voltage through there and seeing through a meter, see what our current draw is and our voltage across there. Now again, if you remember from your math, let's just say that if we have 2.4 ohms of internal resistance, we have a 12 volt system. Again, 12 divided by 2.4 gives me 1 point something amps. So when we read our amp reading, we should come up with a reading that is within the specifications. Now, the other thing is when we're cleaning the slip rings, if we're reassembling this and the brushes have not worn a groove and the slip rings are repairable, you can actually put this on a lathe and you can clean these up and then just sand them nice and reuse them. But if they're grooved for the brushes, they're no good. You can't, you got to replace the rotor. When we're disassembling the rotor or the front case, these bolts here hold a plate in that hold that bearing in. Make sure you take these bolts out before you try and push everything apart because you don't want to break that case. Replacing brushes, again, when they become 50% worn, it's time to replace them. Now, the other thing we want to check is the voltage regulator. Now again, it's controlling how big that field is going to be. So if we keep boiling a battery, when Delco first came out with these, this style of voltage regulator, it was electronics, it was new. They were always failing. But what we can do is we can hook this up. Now, when we turn the key on, this system is set up that the test light is going to come on. So what we have is we have our fast charger that simulates the alternator is charging. We have our voltmeter and we have a set of batteries. What we're going to do is hook it up like this. And we're going to turn our fast charger on. What we're going to do is we want to watch our voltmeter. We want to see at what voltage that test light turns out at. Because again, at 14.5 volts, we're getting pushback from the batteries. It should tell this voltage regulator to stop charging. So that's what we're going to be watching for. We can use, this can be a 12 volt system too. So what we want to know is what is the voltage that this is, at what voltage that light goes out at. Now when we're reassembling, and again most of you probably are just told to replace the alternator, don't worry about disassembling it. So if you ever have to disassemble it, on the back case here, this is where there's a little needle bearing and you can press that out and press a new one in. On the front case of this one here, this one only has 3 bolts and they're on the inside. So what you have to do is you have to take the rotor out first and then you can undo those and press that bearing out. Now you can get kits for these to replace all the bearings and the brushes. Okay, so here's the 3 screws you're going to take out, take that steel cover off, and then you can take that bearing out. And when we're going to reassemble it again, is make sure that we assemble that pulley and the nut on properly so that we're not going to wreck any internal components by using an impact. Now, as we're going back and reassembling it again, we want to make sure that once this is back in place and we have our components there, that we've got it hooked up properly. If I take my meter and I hook onto the positive diodes and I go to ground and it shows 1.1 ohm of resistance, that means that that positive heatsink is grounded, and as soon as I hook that up to a battery, my diodes are going to go poof. So make sure that you put it back properly. So any of our insulating washers, again, we want to make sure we put them back together properly so nothing shorts out. Now, one of the things that's different is on a Elise Neville, again, we can get to the voltage regulator and we can take it out and change it. Now, on a Delco Remy, it's built inside. So, in order to get to my voltage regulator here, I have to take this whole thing apart. On a Elise Neville, I've got 4 screws, I can take that voltage regulator out. And the other thing that Elise Neville has, it has an adjustable voltage regulator. So after we finish putting it all back together again, you can put it on a test bench, and what this does is it will simulate a load and make sure that my amp output works. We used to have one here until someone did something and blew up, but we always want to check it. Now, what's a capacitor for? Again, anytime we have voltage spikes, it's going to control that and keep it nice even voltage. So how do we load test? Again, what we're going to do is we're going to use an amp clamp. We're going to have a load tester on our batteries, and we're going to simulate a load and to see what the output of that alternator is. So if I have a 150 amp alternator, I don't want to, I can, by putting it on the batteries, I can bring it down to say 200 amps, and it's not going to hurt anything. If I hook this up to the alternator and try it, I can fry the alternator. So really, again, always hook up to the batteries. Now, anytime we're taking alternators off, number one is disconnect the power. Know which one's positive, which one's negative if they're not marked, so that we put them back. Because if we put them back backwards, we're going to short something out. When we're adjusting the belts, make sure we get our belt tension proper. Make sure our pulleys are in alignment. Dielectric grease on components that might become corroded. This is Elise Neville. Now they've just got a clear cover on there to show you. So there's a little plug there, we can take that plug out, and we have a potentiometer inside. We can adjust our voltage. So let's just say the batteries keep overcharging and I'm getting 15 volts. Too high. So I can go in and I can turn that potentiometer down so that it can control that. Or if it's not charging enough, I can go in and I can turn it up a bit. And that's it.